Today I'll be talking about harmful algae blooms in Lake Erie. So what are algae? Algae are these microscopic plants that can be found in nearly every body of water worldwide. They're very important to any ecosystem because they are the first step in the food chain of the ecosystem because they are feed for smaller fish. So these algae could range from being small plants that you can barely see to these thick seaweed-like mats that take up the entire surface of the lake. So harmful algae blooms are basically when you have too much algae. And like algae, these harmful algae blooms are found not just in the US, but the entire world. So this map shows you which states in the US have a harmful algae bloom or have a poisonous harmful algae bloom. And as you can see, most of the map is green. So particularly in the US, where we have a different, more industrialized way of farming, we have more frequent harmful algae blooms. So why are algae blooms harmful? They're harmful for three reasons. The first reason is that harmful algae blooms are toxic. So species of harmful algae, like cyanobacteria, they release toxins into the water that they inhabit. And these toxins have been known to cause diseases like ALS and Alzheimer's in humans. A study even found that those diseases, ALS and Alzheimer's, are more prevalent in areas with harmful algae blooms as opposed to areas without any harmful algae blooms. So aside from having an impact on humans, little fish in the body of water also get affected by these toxins because they just can't withstand to survive with those conditions. So when a small fish dies, the big fish that eats that small fish, that big fish is also going to die because he doesn't have any food anymore. And when that big fish dies, the even bigger fish will die because he doesn't have any food. So this small little ripple in the aquatic ecosystem can set off a catastrophic chain of events. So the next reason why harmful algae blooms are harmful is because they create these things known as hypoxic dead zones. So when algae are on the surface of water, they emit oxygen because harmful algae use photosynthesis to survive. But when that same algae dies and goes to the bottom of the lake, and it gets replaced by new algae, as that algae is sinking down, and once it hits the bottom of the lake, it gets decomposed by something known as saprotropes. And saprotropes, along with other bacteria, as they decompose the algae, they take in dissolved oxygen from the body of water. So basically what happens is, as the algae dies and decomposes, there's less oxygen in the body of water. Because of that, you'll have these areas in water where fish just can't survive because there isn't oxygen anymore. So what happens is the bottom layer, or towards the bottom of the lake, you're basically going to have no oxygen. So fish that tend to live in the bottom of the lake are going to move up to the top of the lake. And that messes up the ecosystem because there's a pH change, and also if a smaller fish is at the top of the lake, then it's more competition for food at the top of the lake. So small things like that can devastate aquatic ecosystems because of algae. And algae blooms also cause millions of dollars in losses annually because they're just expensive to deal with. So tourism and recreation, if there's algae on lakes or rivers, people are not going to want to fish there or kayak there or do anything there because it doesn't look good, and nor is it healthy for you. Furthermore, the toxins that algae releases, they're also very hard to filter. So cities and governments have to spend numerous amounts of dollars, or really they have to spend a lot of money to try and filter these toxins from water before they can drink it. And then commercial fisheries, so again, people can't fish from the lake because it has too much, the fish are toxic. So they have to find other means to fish. So that has a direct impact on their fisheries. So now this is a satellite image of the harmful algae bloom in Lake Erie. And all these green almost filaments are the algae. So this image was taken from the NOAA, or the National Oceanic and Atmospheric Administration. So just keep that in mind, and I'll explain why that's significant later on in my presentation. So this graph shows you the severity of harmful algae blooms ever since 2002 to now. And as you can see, there is an upward trend. It's a weak correlation, but there's definitely an upward trend from 2002 to 2017. So what that means is that as time progresses, these algae blooms are getting worse and worse. In 2011, we had the worst algae bloom ever recorded in human history with a severity level of 10. And in 2015, it was something similar, but even worse. So for 2017, we're likely to, it's not going to be that bad, but there's a possibility that it could be that bad. So this is a satellite image of the 2000 level harmful algae bloom, and to give you some perspective, this was a level 10 harmful algae bloom. And so now this is a satellite image of the 2014 harmful algae bloom in Lake Erie, and keep in mind that this is near the city of Toledo. So can you guys guess what happened next? In 2014, the city of Toledo had to shut down drinking water, or tap water, for more than 500,000 of its residents, because that water was toxic with the species, or with the type of toxin known as microstisis. So microcystis is deadly to the human body because it could cause for liver failure, cardiovascular diseases, and it could cause for headaches and along with other neurodegenerative diseases. So what basically happened in Toledo was for a really long amount of time where the water was not being tested, these people were drinking water from Lake Erie, and their water had this known toxin, microcystis, which is deadly to the human being. Until one day the government decided that, hey, let me test the water, and they found that this actually was in that water, so they had to shut down tap water for the entire city. So for a good week or so, that city just did not have any tap water, and they had to get water from other sources. So it's kind of like the Flint, Michigan crisis, but with Toledo. And so what's even more threatening about this is that 11.6 million people in both the US and Canada rely on Lake Erie for drinking water. So it's not like if I just have algae on near the Toledo side of the water, those toxins are going to spread to the entire lake. So it's not like Canada won't be affected by what the US is doing, or the US won't be affected by what Canada is doing. This is a truly international problem. And the algae, if you have even the slightest algae in a lake, it's going to spread because it's soluble. So keep in mind that the drinking source of 11.6 million people is potentially at danger because of harmful algae blooms. So this is a chart of the dissolved oxygen levels in Lake Erie. And all this chart really means is it shows you how much oxygen is in Lake Erie. And as you can see, a large portion of Lake Erie towards the center does not have any oxygen. It's hypoxic, it's in the 0 to 1 ppm range. So what that means is that fish cannot simply survive in a great portion of the lake. And the rest of the lake, which is yellow, that also means that that part of the lake has really low oxygen levels. So right now, this is what it looks like, but if you continue with this trend, eventually this entire lake would be purple and it would be a dead lake. So in the 2011 harmful algae bloom, which was the worst on record, approximately $71 million were lost in economic benefits. So this cost is broken down into $16 million for lost property value. So all the numerous homeowners that have lakeshore properties or timeshares on the perimeter of Lake Erie, their property value significantly decreased in just that 1 year. I mean, the long-term effect or the long-term value of that property decrease is near $1 billion, but just in that 1 year, $60 million are lost in property value. And that came from people not wanting to buy those properties again because it's near a dirty lake, it's a dirty view of the lake because the lake is now fluorescent green. The second cost was $20 million lost in tourism. So Lake Erie had, I emphasize had, they had a booming tourism business because it's in the US side of the border, and it's around 3 states. So I mean, numerous people would visit Lake Erie every year, but now with the harmful algae bloom, that water is toxic, it doesn't look good, and it feels kind of icky to be swimming in water with these thick filamental-like algae. So $20 million are lost in tourism. $31 million are lost in recreation. So residents of the Lake Erie area, they couldn't go to the beaches anymore. They couldn't do anything on the lake like kayak or fish because it was a health hazard. And then $4 million are lost in water treatment. So cities like Toledo had to start implementing these really expensive systems of filtration to remove toxins before they enter the mouths of their residents. So to give you some comparison, the Exxon Valdez oil spill cost $7 billion. So this compared to the Lake Erie harmful algae bloom isn't that much because it only cost $70 million. But if you look at it again, that's $70 million over, so harmful algae blooms happen every single year. And they're predicted to happen for the next 20 years, and they've been occurring for the past 30 years. So you're looking at a range of approximately 30 years. With each year, you have a lost economic benefit of approximately $70 million. So over time, if you have harmful algae blooms for 30 years, your lake is going to become dead. So the long-term cost of these harmful algae blooms is much more than $7 billion. So another big problem with harmful algae blooms is the recent budget cuts by the Trump administration. So the NOAA had a budget cut of $513 million, and that caused for an 80% decrease in the funding of the satellite program. So in my presentation, all the images I had were from the NOAA. All the satellite images, all my stats, all my statistics, they all came from the NOAA. So what's happening is these algae blooms are continuing to become worse, but the funding for the organizations that are supposed to deal with them is decreasing. So you have an increasing problem, but less and less resources to solve that problem. So that's also one more challenge facing Lake Erie. So causation map. So why does Lake Erie have a harmful algae bloom? So the 3 scientific reasons for an algae bloom anywhere are excess nutrients. Should I move the map, Ms. Eagle, or the board?
I'm tilting it a little bit. Can you guys still see?
So there are two scientific reasons for why algae blooms occur. The first is excess nutrients. So nutrients can be found in anything from fertilizer to human feces, because all living organisms need nutrients like phosphate, which is DRP phosphate, just a fancy name for a nutrient, and nitrate, NO3. So these nutrients are found in anything from feces to fertilizer. So when you have too many nutrients in a body of water, you're basically just overfeeding the algae. So the species of algae that was traditionally in that body of water is going to have too much food, so it's going to overpopulate. So excess nutrients are a big cause. The second big cause is warm temperatures and weak water currents. So algae like warm water because they just thrive in warm water. And so Lake Erie is really shallow, and it's a lake. So these two are geographical reasons. So because it's really shallow, there isn't much circulation in the lake itself. So that causes for warm temperatures. Furthermore, is there a question, Justin?
Oh, no.
Oh, sorry. But yeah, so warm temperatures and weak water currents. So because it's a lake, there really isn't that much water flowing into the lake. Or there is, but from rivers, but it's not significant. So that allows for the algae to remain stagnant and grow their base without having to worry of being wiped out by a wave or something. So because it's a lake and it's really shallow, you have warm temperatures and weak water currents. And global warming also plays a large part in this because it's just the Lake Erie region, or the Great Lakes region, has been warming up in the past 10 or so years. So partially Lake Erie's algae bloom is caused by geography. But what's the big reason here is these excess nutrients. So there are two sources of nutrients coming into Lake Erie. The first source is non-point runoff, and the second source is point pollution. So all that non-point runoff means, or non-point sources, they're sources from farms and gardens. So these are just dirty water being run off, or dirty water running off of a property, and it's not really regulated. So that's non-point runoff. And point runoff is water coming out of, let's say, a sewage treatment plant or a city. It's water coming out of a pipe that you know is coming from this source. But non-point runoff, it's much harder to regulate and test. But in recent years, these green bars, which symbolize non-point sources, these green bars are beginning to increase, and they're undermining the red bars, which symbolize point sources. So what these mean, or what this graph is trying to say, is that in recent years, non-point sources are the major cause of why harmful algae blooms are occurring.
A quick question. It looks like it started in the 70s. Is that because that's when they started measuring non-point versus point sources?
I mean, definitely, yeah. So the reason why these non-point sources are beginning to overtake point sources are because of, largely it's because of the Green Revolution. So because of industrial farming and such, you have more fertilizer being put down, and I'll get into the science of that later on. But yeah, so I think does that answer your question, Ms. Eagle?
Well, I'm just looking at, is it the case that there was none in 1972, or did they just not start distinguishing between point and non-point sources until this looks like the mid-70s?
Yeah, I think it's the latter, because it's really hard to know that this water coming into this river or lake is coming from this farm in X area, because it's really hard to differentiate that.
Good question, where did this come from?
Where did this graph come from?
Yes.
It came from the Ohio Lake. It's written right there, so it's a credible source. And then I'll get into why that task force exists later on. So, but yeah, so you have two sources of non-point pollution, or two sources of pollution, non-point and point. So this is a map of Lake Erie, and on this map there are two major rivers. The first is the Maumee River, and the second is the Cuyahoga River. So these two rivers exist because of geographical reasons, but what's interesting is that this Maumee River is largely the reason why you have non-point pollution. So this Maumee River is taking in pollution from farms and other homes and dumping it into Lake Erie. And the Cuyahoga River is a source of point pollution. So a lot of cities and wastewater plants lie along the Cuyahoga, and they dump their waste into the Cuyahoga. So now, why? So as you can see on this graph, the arrow symbolizing the Maumee River is much thicker than the arrow symbolizing the Cuyahoga River. So what that means is that the Maumee River is mostly water. The Maumee River contributes more pollution to Lake Erie than the Cuyahoga does. So that again shows that non-point pollution is really the major problem here. So this shows you the annual DRP loads in the Maumee River, and all that DRP means is nutrients. So in recent years, you've had a lot more nutrients in the Maumee River. And why is this occurring? This is occurring because of dirty runoff. So now we'll move on to my causation map here. The Maumee River has a lot of nutrients. It has a lot of nutrients because it has a lot of runoff. So why does it have a lot of runoff? It has a lot of runoff because of Sorry. Okay. So in this graph, what you see is that this area here, our target area, which is right near Lake Erie, has really dirty runoff. It's 15 times worse than water quality standards. And so because it has a lot of runoff, you have a lot of DRP, or nutrients, in the Maumee River. And why do you have a lot of runoff? Well, partially it's because of all the rain. So in recent years, we've just been having a lot more rain in the Lake Erie area. And that's because of global warming. But because of all this rain, you have a lot more things, or you have a lot more contaminants running off of farms and such areas. So now, why is there a lot of runoff? It's because of this. This is the Lake Erie watershed. And all that a watershed really means is that if I were to say, if I were to drop a gallon of water in, let's say, the county of Lima, that water would eventually find its way into the Maumee River. So it's basically all the areas that are uphill of the Maumee. So runoff from all these areas tends to end up in the Maumee River. And in that same area, or particularly Ohio, which takes up a large part of the Maumee River watershed, you have a lot of farms. So this graph shows you the quality of the farmland. I couldn't find a graph that shows you what types of farms or how many farms exist in these areas, but this area is really fertile, so it's safe to assume that there are a lot of farms in that area. So because you have a lot of farms in the Maumee River watershed, you have a lot of dirty runoff going into the Maumee. So now, why do farms lead to dirty runoff? Well, farmers often over-fertilize their crops with commercial fertilizers. So largely this is because of the Green Revolution, because now most crops are GMOs and they require more nutrients than, let's say, your average crop would. So farmers fertilize because of that, and they also fertilize because of farmer greed. Farmers just want more output from their land, so they're going to put in more fertilizer. So there's farmer greed. There's also weak regulation. So agriculture is a massive industry, and they have a lot of lobbying power. So it's really hard to enforce any laws upon farmers just because there are these massive farmers' unions. So weak regulations. There's also a lack of knowledge. So most farmers don't know that because of them applying this fertilizer on their field, they're causing for this massive algae problem. So there's lack of knowledge, and the main cause here is farmers are just not planting cover crops. So cover crops are basically crops that you plant after your main growing season's over. So let's say if I'm a farmer who plants corn. For the majority of the growing season, I'll be planting corn, but after the corn season's over, like if I were a farmer in Ohio, I would just leave my field barren and I wouldn't plant any cover crops. But me doing so allows for a lot of nutrients from my growing season that are still there to just run off and go into the Maumee River. So cover crops are a massive reason why you have this problem. So the second source for farm runoff is KFO. So KFO stand for concentrated animal feedlot operations. So it's basically industrial farms where you have a really high density of things like cows and other animals living in a really small area. So because of the Green Revolution, you have these industrial farms, or KFOs. And because of the Green Revolution, you have an inorganic diet for these new animals, or these cows. And because of these inorganic diets, these cows tend to defecate more. And cow feces has a lot of nitrate and phosphate, or a lot of nutrients. So because you have a lot of these cows in a really small area, and when it rains, all that feces is going to run downhill into the Maumee River, so you're going to have a lot of nutrients in the Maumee River. So cows and plants are why you have a lot of nutrients in the Maumee River. And then, so before I go on to my key stakeholders, something I forgot to explain is, so these are all non-point runoff, and then for point runoff, or industrial runoff, you have cities and sewage treatment plants. So when it rains a lot, cities or sewage treatment plants, they just can't filter gutter discharge as fast as it's coming in. So after some point, they have to just open a valve so it all goes back into the Cuyahoga. So because of a lot of rain, which is occurring because of global warming, you have a lot more cities dumping dirty water into the Cuyahoga. So that also causes for nutrient in the Lake Erie because it's two sources of pollution. So now we'll move on to my key stakeholders. So the key stakeholders in my, should I move the board so you can see the board?
I see the stakeholder.
Okay. So the key stakeholders in my project would be four groups. First is the public. Algae poses a really big threat to the public because it's toxic and it chips away at their lifestyle. And then you have the farmers. Farmers, I think farmers, most of them don't want to harm the environment, but they're just reluctant to, they don't want to change their practices. So there's definitely it's a really controversial area, but farmers definitely have a stake in the Lake Erie harmful algae bloom. And then the Ohio state government is also very influential because most of the Maumee River watershed, which causes for the harmful algae bloom, is in the state of Ohio. And furthermore, the state of Ohio also has a large part of the U.S. Lake Erie shoreline. So a lot of the Ohio industry is coming from Lake Erie, as well as the agriculture in this area of Ohio. So the Ohio government has a massive stake in all of this. And then the last thing, you have local business owners. So local business owners like local fishermen or local kayak shops or stuff like that, they can't live anymore. They can't make their daily bread and butter if there's a massive algae bloom on Lake Erie. So these are all the stakeholders in my project. So what's being done to implement this? So right now you have the state of Ohio trying to set down laws and regulations on the way farmers apply fertilizer. But keep in mind that this act is basically the first act, and the Great Ohio Task Force that I mentioned before was in one of my sources. That task force also started in 2010. So these problems have been occurring for the past 10 years, but the solutions to them have only been started not too long ago. So what Ohio is doing right now is it's basically banning farmers from putting fertilizer on their field at really bad times, or it's limiting how farmers can apply fertilizer on their field. But why I don't like this is it's really hard to control and regulate non-point sources. So it's not like the Ohio government has like a overseer or the police checking on these farmers every day. And it's not like the Ohio government can see that, hey, the runoff from this farmer's property is really polluted, because it's non-point runoff and that water can flow off in any direction. So while this is a good law, it's really hard to enforce, and it's kind of unfeasible because it's not doing much. So like this law was put into action in 2014, and as you can see, even in 2017, we're still having a harmful algae bloom. So while this is a step in the right direction, it's not particularly the most effective way of preventing harmful algae blooms. And the second thing here is the Great Lakes Water Quality Agreement between the US and Canada. So this agreement is effective in the sense that it basically broke down at the international problem of solving Lake Erie and the Great Lakes water problems, because the US and Canada have agreed to work on it together to prevent these problems from happening. So if you look at the Canadian side of Lake Erie, it's pristine and clear, but the US side, on the other hand, is not. So you do have international cooperation, but the US isn't doing its part in that cooperation. And this here is a screenshot of the Ohio Department of Agriculture website. And as you can see, on their main page, they have this thing known as fertilizer applicator training. So this is different from what Ohio did before with just banning fertilizer or putting restrictions on fertilizer. Now they're trying to educate farmers and make sure that what they know, or make sure that they know that what they're doing is harmful to the environment, and it's having them certified so they make more environmentally friendly decisions. So I like this because this is a good step in the right direction, because farmers to be the most, so before, while I was doing research, I went on a lot of websites for farmer unions, and they vehemently opposed any type of government regulation that tells them what to do with their farms. Because keep in mind that these farmers are generation farmers, so they've been keeping their farms for the past 60, 70 years. So it's really hard to get a farmer to change his practice, but if you educate a farmer and make him want to change his practice willingly, you'll have better results. So this new law where farmers are supposed to be certified was a recent development, so like 2016, early 2017. So now, what do I want to do to solve this problem? So the main solution to this problem, in my opinion, is cover crops. If you have cover crops, you're not going to have runoff. So I want to incentivize farmers to grow cover crops. So planting cover crops reduces nutrient runoff by 40%, because what happens is these cover crops, when you put them in soil, so cover crops like oat and barley, they don't take that long to grow, and you grow them after your main growing season's over, like I said before. So by planting these cover crops in your property or in your farm, their seeds or their roots expand, and they basically make it better for the soil to absorb nutrients. They make your soil healthier, and they just prevent runoff from happening because they make your soil more compact and less loose. So it just basically prevents runoff. And so cover crops also prevent runoff, and they cause for a better harvest the following year, because if your soil's better, you're gonna grow more of your main crop. So cover crops are basically an ideal solution to this problem. They help kill weeds and other pesticides, so that saves farmers money on doing that. So yeah, cover crops are basically amazing. But the thing with cover crops is they're like solar panels. So solar panels have a very small, or solar panels are really beneficial, but to implement them in the first year, it's very expensive. But in the long run, you'll actually end up saving money. But just to get past that initial confrontation of buying solar panels and setting up a system, that's very expensive. So that's why most farmers are kind of reluctant to do this on their farms. So the main obstacles that I face with my problem First being money, second being lack of knowledge, and then lastly being just refusal to change or unwillingness to improve. So with money, so this is this shows you the costs for planting cover crops. And as you can see, cover crops in that first year are very expensive. So these costs are broken down into a cost for buying the seeds. Just to plant cover crops your first year, you have to go obtain the seeds from somewhere, and just buying that seed itself is pretty expensive. Planting the cover crops is not too bad, but then initially fertilizing them is kind of expensive. So while cover crops are supposed to reduce fertilizer, when you first grow them, you have to put this really complex fertilizer to help them grow. But after that first year, it's all really easy. And the really big problem here is termination. So you have to terminate your cover crops before your main growing season starts, and that requires a lot of hard work. So most farmers also have that obstacle because they don't want to spend 10 hours before their main growing season just terminating all these crops. I mean, it's more than 10 hours, but to make an analogy, yeah. So there's a lot of hard work required with growing cover crops. So another big problem with this system is that most farmers don't actually own the farm that they work on. So this is our target area right here between Ohio and Lake Erie. And as you can see in this target area, most of this area is red, which means that approximately 50% of farms are not owned by the farmers. So while you do have these generation farmers, you also have these farms that these farmers who move from farm to farm every 6 to 7 years. So they don't really care how they're hurting the soil of that farm, or how they're they don't care how they're making that soil acidic and salty, because by putting all these fertilizers, you're basically just making the soil salty and acidic. But because they know that in 6 to 7 years, building them into a new farm with new soil, they don't really care about that. So a large problem here is also the lack of ownership of most farms. So now this is an excerpt from the New York Times. So what happened is one of the journalists here, they went to a farmer in Ohio who does plant cover crops, and they interviewed him. And what surprised me is that this is the quote of the farmer. And what this quote basically says is the neighbors of that farmer who don't plant cover crops, they're really critiquing him for planting cover crops. Cover crops kind of look ugly when you're planting them, because it's not just one species of plant, it's numerous types of plants. So while one may be growing, the other might be decaying, and so on. So it doesn't look visually appealing. So that kind of agitates other farmers who don't plant cover crops. And there's also just plain out skepticism or ignorance. Most farmers just don't want to take in new methods because they've been doing these methods for a long time now. So there's also that social obstacle regarding just not wanting to change. So now the state of Maryland, they did a really great thing with incentivizing cover crops. So they made it easier for farmers to get past that initial barrier of not having to spend that much money to get cover crops for the first year. So the state of Maryland basically gives its farmers money to buy cover crops and put them in for the first year. And if farmers meet all the requirements set by the state of Maryland, such as not applying too much fertilizer and growing cover crops, they'll get a financial incentive of like $67 per acre. And the surprising thing is, this has been extremely effective. So who knew that money would cost for people to do things? More than 50% of all the farms in Ohio now have in Maryland now have cover crops. So this theory of incentivizing farmers to grow cover crops has been tested, and it's proven to be effective. And you think it's really expensive, but it turns out it's actually not that expensive. So Maryland's program only costs $22 million. When you compare that to the U.S. corn subsidy, which is greater than $10 billion, $22 million is practically insignificant. So it's not like there's a lack of money for Ohio or the U.S. to implement this, it's just there's reluctance. So food and agriculture in Ohio itself is a $105 billion industry. So if this were to be implemented in Ohio, it's not like there is a lack of money in Ohio to implement this, because Ohio has a great and a booming agriculture industry, so they could easily implement this. So now how do I want to incentivize farmers to do this on their fields? So the first is tax breaks. So if farmers plant cover crops, they'll get 1 to 2% tax break on their crops or produce. So that would give them that financial incentive. The second incentive is to give them just straight out financial aid, like what Maryland did. So the Ohio government could set up a program where it gives farmers money to buy seeds for cover crops and buy other stuff to grow these cover crops, and that would help them get past that initial obstacle. And the second thing is, and the last thing is subsidies. So right now, the USDA, which basically buys the crops that we eat for school lunch, they spend approximately $2 billion every year on buying these crops from farms nationwide. So what I'm calling for is a reallocation of these funds. So right now, like 80% of all the crops that the USDA buys is corn. So what I want is for 70% of those crops to be corn, and the other 5% could be oat and barley. So oat and rye are two crops that are really great at absorbing nutrients, and they make your soil healthy. So instead of having something like pizza on Fridays, I think we all like pizza, but instead of having something like wheat bread on Fridays, we could have oatmeal in the morning and rye bread. Like small things like that would give farmers an incentive to grow cover crops because they know that the USDA will buy them. And then my second recommendation is scientific research. So I think the solution to harmful algae blooms is not something that just farmers can implement or just farmers can do. There has to be a coalition between science and the farm. So what I want is for the USDA to start these research competitions or research prizes where they give money to scientists if they find an effective way of solving this problem. So, like right now, the Heidelberg University, which is a university near Lake Erie, they work with the USDA to forecast algae blooms in Lake Erie and how to prevent them. And they've been really accurate. The graph that I showed before with the increase in severity problems, that was made by Heidelberg University. So this system, or this coalition between the government and science, is effective, and Heidelberg University is a great example of that. So the George Barley Water Prize and the Stockholm Junior Water Prize, these are just some examples of non-US privately run water competitions which seek scientists worldwide to find solutions to things like algae blooms and water contamination. And every year, more than 200 scientists enter these competitions. And the prize money is approximately 100K. I entered these competitions too with my research project. So it's really great because you have all these scientists who want to make a change and they have an incentive to make a change because there is a significant price. So the prize could be something as small as 100K for a government, but for a scientist, it's a really great amount. So there definitely has to be a correlation between science and the government. So instead of having these privately run science competitions, maybe the government could run these science competitions because then it's easier for the government to implement these solutions in the actual field. Like the George Barley Water Prize, they can't really implement the solutions themselves because they're not a government. But if it was the USDA, they could take that solution from a scientist onto a farm or onto the actual field and do it. So that's why government and science need to work together. So the estimated costs. For the lunch program that I want to do, there really isn't that big of a cost, it's just reallocation of funds. For the tax breaks, the state will not actually lose money, they'll gain money. So cover crops make your soil healthy, and they cause for better harvests. So while you're getting a 1 to 2% tax break, next year that farm is going to produce 6 to 10% more crops. You're making up that tax break and you're getting more taxes. So tax breaks are not really a big problem. And then regarding the financial help, for a state like Maryland, it was $22 million to implement their cover crop program. Something like Ohio, it could be approximately $30 million. But then keep in mind, Ohio's industry is a $105 billion industry. So that's not a big problem for them. And then for the research programs, it could be something as small as $1 million or something as large as $2 million. Right? That cost is really dependent on what the USDA wants to do, but it's pretty insignificant when you look at the income that agriculture brings. So my metrics of success are not that complicated. The input would be money and laws. So you need to get these laws out there that say that we'll help you out to buy these cover crops or we'll give you tax breaks and stuff like that. And you have to put in some money to give these farmers financial aid. So that's the input. The output would be you're incentivizing farmers to grow cover crops and you're cleaning the runoff that comes off of their farm. And how do you measure? Because my topic is very scientific, it's really easy to measure the outcomes. So you could do a simple surface area test of Lake Erie to see how much algae is there, or you could see how much phosphate is in the Algae River. So it's really not that hard to measure these outcomes, but what's really hard is getting these inputs. And so these are just my references. Thank you.
Since we have 3 minutes, could you tell us how the research you did for the science fair fits into, because that's where you started, and you didn't even end up mentioning that. Can you tie them together?
Oh yeah, so for the past 3 years now, I've been trying to filter nitrate and phosphate, which are the two nutrients that cause algae blooms, using mushrooms. So mushrooms are really cheap and easy to grow, and they help other plants grow. So how I imagine doing this is, like, after I get successful results, which I kind of have this year, I want to grow mushrooms on farm, so runoff from that farm could be taken by the mushroom before it goes into an actual lake or a river. So yeah, that's something that I'm working on right now, and I've been doing it since 8th grade, so there's definitely success there, but I'm just a high school student. I'm sure that there's a scientist somewhere who can think of a better solution than I can. So that's why I want to advocate for more funding for science programs. I mean, with the George Barley Water Prize, I entered that 2 years ago. I mean, I made it past the first level, but still, it's like the amount of projects and their quality was just so amazing. I think, yeah, there are definitely people who want to cause a change or who want to implement a change, but they just need an incentive. So the government needs to do that. But yeah, that's what I've been doing with my research. I think we have time for questions.
Go ahead.
Questions. Oh, you mentioned the tax break. What percentage did you say that was?
1 to 2%.
2%. You mentioned in the beginning that algae blooms happen every year. Are those seasonal or are those sometimes?
Well, so algae, like warm weather, so they are seasonal. So that would happen every summer. And sometimes, because we have warmer temperatures now, that algae bloom is going past the 3 summer months to be like early fall and early spring even.
You said open barley growing. How fast is the growing season?
So the growing season for cover crops is it's like 1 to 2 months. So it's a lot easier than growing your main crops. So it's definitely a feasible solution.
How hard would it be to time growing certain cover crops in order to reach the specific times in which algal blooms are projected to happen?
Well, so during the main growing season, so what happens is if I were to grow cover crops, let's say after my main growing season, which is spring, and I grow them the winter, next year when I don't have those cover crops, my soil is just going to be a lot better. So even if I do plant my actual crops in the next growing season, which is when algae blooms occur, there isn't going to be that much runoff because that soil is just going to be a lot better at absorbing nutrients, and the plants themselves are going to be better at taking nutrients. So does that answer your question, kind of?
Finally, you went to this whole project without mentioning microfiltration, which is what your project is about. Would you plan on implementing that if you were to get the opportunity to actually present this to who you want?
Definitely, yeah. So at one of the science fairs that at the LA Science Fair, there was this guy who was doing the same thing as me, but using a different substance. So I used mushrooms. He used this bacteria. So he was able to get the Department of Agriculture of his state to give him permission to implement this. So that's definitely something I'm looking to do this summer, to go to the NJ Department of Agriculture and try to get this implemented, but it's not looking too good right now. But I will try.
Good luck.
Thank you.
Thank you.